Maybe because we just can never learn enough.
I think that's right.
Yeah. All right. Let's get started, folks. My name is Margarita Rivera. I'm a soil health planner up in Tremont, Utah. And I'm here to introduce you to Jill Clapperton. So if we could give her a hand.
All right, here I am again. All right, so this is the last one of the three, and they are all different. So it's been kind of hard. I apologize because I know they're breakout sessions, and then you end up. So the one that we had earlier on sort of gave a bigger overview, but this is for people who really are trying to make the transition to no-till. The whole idea here, first off, is that everything is connected. So, you know, this is Gaia theory. And I'm now in Massachusetts, the home of Lynn Margulis. And she really pioneered this theory, and then James Lovelock worked on it as well, where everything is connected. And so I just want you to understand that this is a system and everything is connected. And then we saw this graphic before, just reinforcing that it's the biology. And what we're trying to do is create a biological system where we get biological fertility. I mean, that's what we're really striving for. And we can't do that as long as our soils are really disturbed. Now, we have potatoes, we have onions, we have things, like we have root crops that we grow. So we're going to do some disturbance. So part of this is mitigation. Like, how do we recover after we have a big tillage event? Can we recover after a big tillage event? Well, the answer is yes, we can. But we just have to be really committed to that in the end. Like, we have to really work at it. So, yeah, sure, go for it. Oh, okay. Okay, so you've got a feedlot, or you've got, okay. So you're used to incorporating it. Is it composted? Then you have no choice. You're going to have to till. Because those are the regs, right? You only have certain times that you can put manure on. Okay. Because a lot of other places have regs on when you can put it on, and okay. And you do have to till it in then. Is that a regulation or not? Okay. When you think that you're going to preserve the nitrogen, just give me a little bit more information on that. Like, okay, well, volatilization of nitrogen is going to occur even more with that disturbance. And I get it. You're trying to bury it under the ground so that it can't volatilize anymore. Part of that is also manure is a really valuable source of phosphorus and an exceptionally valuable source of organic matter. So I've actually put it on the surface at different times, like sort of more to the late fall, getting into winter. But I really prefer it to be composted. That's the better way to do it. And that's not about, if you put on raw manure, you're just not getting nitrogen. You get a lot of other things. And it can be too hot, and it can be toxic, and if you put it on raw, you get too much salt usually, and that's a real issue for soil biology. So composting it is actually a better deal if you can do it. Manure is always going to be an issue with feedlots because you can't go far enough away, you can't truck it far enough away. I mean, there's just a whole bunch of issues. Composting is probably a better way to go, but then you have to use more room, right? You have to set up a pad, you have to do some things like that. If you're going to use more sort of raw manure, I don't think the tilling is going to help that much with the volatilization. But light tilling, and I mean light tilling, not heavy tilling, is probably going to help you if you can do it like a ways before the crop. So if you can do that in early spring or you can do that in late fall, it's probably going to be better. And I'm still, and at your state, you know, when it's semi-raw, I'm going to incorporate it, and I'm going to wait 2 weeks before I seed. Just to I mean, because you can't plant plants into compost, like straight compost. They aren't going to do very well. And it's the same with manure. You can't plant them into straight manure either. So, you know, and how many tons are you putting it on annually? Too much. What that means is too much. Okay, well, you're going to have issues no matter what, because you're going to have buildup of salts, buildup of other things. And the one thing I'll tell you, really early on in my career, I was in Virginia at the first no-till meeting in Virginia, and there was a man, Kenneth Nicely, and Kenneth had broiler chickens, and he thought that manure was like, poultry manure was really good for the ground. Kenneth has more phosphorus in his ground. I mean, it's sort of like you could mine it because of all the manure that he put on. And now we have to put on more fertilizer because the phosphorus ties everything up. And so now we're putting on nitrogen. It's a never-ending cycle. So I'm going to warn you, I think that I would go to composting a little bit to get rid of some of the heat of some of the nutrients. And if you're putting it on every year and you're putting on too much, you are building up a lot of nutrients. And I can tell you, yeah, because if you get too much, you never get rid of it. I mean, we were growing buckwheat till the cows come home on Kenneth's soil, just trying to mine out some of the phosphorus. And fortunately got a contract with Martha Stewart for buckwheat groat pillows. So we could sell all the seed. And we were just like, and literally we were a mining operation. It's like, let's mine. We're just going to mine phosphorus. So be careful. Try composting. There's no solution for too much manure. Waste management's a real issue. And except if you want to just have your cattle walking around out in the ground a little bit more. That's a good solution. It is hard, but you're moving in that direction, and moving is the good thing. I'm going to say moving. I'm all for moving, going forward. So if you build it, they will come, and I'm always going to be looking at if you build it, they will come. So and maybe it's just because of my Scottish heritage, I'm just really cheap, and so I want to, you know, I'm going to try and build things. And I'm not going to try and always inoculate. That doesn't mean I won't if I need to. And composted manure is a great thing. Compost extract's a super thing. I'm going to remind us that predators are really the key to all of this, and that's why we're trying to preserve and have a habitat, is so that we can have predator-prey interactions. I mean, that's the whole goal. And we're trying to build the soil structure up. And, you know, building soil structure is all about carbon. It's about root exudates. It's about organic matter, which again comes back to the manure. It's about building up the organic matter so we have water holding capacity, so we have water, we have more soil structure, we have something to feed everything that's in the soil. That's why we're doing it. That's why we're trying to build up. We're trying to have more ecosystem services. You know, your soil has services in it. It provides you with a lot of services. Not only is it purifying groundwater, it's purifying the air, it is providing you food, it's providing so many services and nutrient cycling, all of these things. You have to think about, we're trying to preserve the services, we're trying to build up the services, we're trying to have more services. And the more diversity we have, the more services we have, which means our system becomes more resilient and resistant to the disasters that we're facing all the time, like these torrential rains. where all of a sudden I'm getting like 8 inches all at once. Well, oh my gosh, you know, how do I hold that much water? I want to hold that much water, but we know it's going to run off. Extreme drought, and then extreme cold, and the whole thing is going like this all the time. How do we build up resistance? How do we, you know, really build up our tolerance to that? I mean, our system has to be working and has to be able to deal with it. So we've already sown this. We have to have fast-growing, healthy plants, which is why we want to have a better soil structure. If we have compaction, our plants are going to struggle. They're going to be weaker. They're going to be more prone to disease. They're not going to get the nutrition they need. They're going to struggle with water. All of that isn't going to help us. Old root channels, and having more roots means more carbon. That's actually carbon, that black stuff, carbon, oxidized carbon. So you can see that I'm actually building soil now. Okay, that's a little bit at a time in a gray wooded soil, but I'm building it. And the more roots I put in, as long as I can grow, maybe I can double crop, maybe I can't, maybe I can put perennials in, but I can build more soil and more carbon-rich soil. Roots that grow in pre-existing channels and in fractures really facilitate water flow. So that's the other thing. We're actually start getting straws going down. So we have more infiltration. We have more water. And now we've got more carbon, so now we're holding that water. So now not only is it going in, but we're holding more of it. And here's a really nice example. That's an earthworm channel, and that root is going in that earthworm channel. Now, roots love growing through earthworm channels. Yeah, it's easy. It's easy to grow through them. There's another reason, though, too. The earthworm, as it moves through the soil profile, leaves mucilage along the edge. And it's loaded with calcium, and it's loaded with carbohydrates and waste products. If the earthworm's well-fed, it'll be ammonium. If it's not, then it'll be nitrate, but either one is a bad deal. And also, bacteria that are plant growth promoting love growing around the drillosphere, which is where the earthworm went, the lining of the burrow. And so why wouldn't you want to grow there? It's a good place to grow. You get beneficial bacteria, you get calcium, you get nitrogen, you get a lot of really good things. So there's a lot of reasons to grow through an earthworm channel. In this photo here, this is in Argentina, and we were having a discussion about how much is too much residue. Now, the person with the pie hat who's looking right into is my friend, my dear friend Alfredo Cabeza. And Alfredo would say, oh, no, I don't have enough residue, I don't have enough residue. And everybody's going, Alfredo, it's like mid-calf. And he's like, no, I don't have enough. And he was the one who taught me about always having green plants and how that stimulated residue breakdown. So a lot of times in dry climates, everybody's like, well, we have a problem with too much residue. I can't get rid of it. And I can't go through it and whatever. And Alfredo said to me, you need to plant a green plant. And I said, okay. And he said, Anna Primavezy says. And I said, Anna Primavezy. And everybody goes, oh, again, not with the Anna Primavezy. No, please, stop. And I said, no, wait. Who is Anna Primavezy? Anna Primavezy died last year in January at the age of 100 years old. Anna Primavezy was a an absolutely brilliant agronomist. She was denied a PhD because she was a woman. But she worked at learning about plants and decomposition and everything else. And she long time ago, in the 60s, said, you need to grow green plants. They help break things down. They start doing these things. So I started reading the work of Anna Primavezy, and I just missed out on seeing her. And definitely one of my heroes. I mean, when I read her work, she was just so far ahead of her time. And, you know, if we'd have been able to really bring the world together more and use the work of Anna Primavezy, we'd all be so much farther ahead. So off I went, Now, this is based on the work of my friend Juca Morales, who is a professor in Ponta Grosso in Brazil. And we started thinking about, well, what are the phases of no-till? Because people often say, well, okay, I transitioned to it. It's a disaster. I'm not doing it again. I have yield drag. I have these things. So what can you expect when you make the transition? 0 to 5 years is tough. Okay? No questions asked. It's a tough transition. You're gonna be experiencing with your soil's experiencing withdrawal. Your experience withdrawal. It's like, oh, I really want to go out and do some recreational tillage. Nope, can't do it. I really, I want to. It's not doing it. The plants don't look as good. I mean, this part of this is this whole idea is now your soil is starting to grow this whole population below ground, and it needs a lot more resources, and you don't have them. It's like Jimmy said at the beginning. He said, well, they were right. I couldn't grow it. Well, of course he couldn't. He didn't have any quality organic matter. He'd probably only been growing cereals, so all he had was a whole bunch of carbon. He didn't have any real nitrogen organic matter. He didn't have any phosphorus organic matter. So now what? I don't have the nutrition in this habitat. I've created this lack of disturbance, but now I don't have the nutrition to feed these guys. So now one of the best ways to start making this transition is from a cover crop or a pasture, because you're already not disturbed. So then moving into the no-till is not that big a deal. Things are kind of done, had their work. And we talked about this. If you can't grow warm season, then think about oats or barley or something with a big root system to come in after that as a cash crop. Okay, so I'm going to do your soil needs rehab. So this is going to be about me, and you're going to get to see my farm in Kansas that I started working with 2 years ago. That's what I got. Yeah, now everybody's laughing. It's like, oh my goodness. Do I know what I'm talking about or what? That is windmill grass, and you can see what used to be a milo crop in there. I am known as the sod farmer in the area because I inherited a sod farm. That's pretty much what it looked like. And there'd been a lot of tillage. There was no nutrition. I mean, when I sowed my first winter wheat crop, the bison got in, my neighbor's bison got in, and it was green, so they ate it all. But the thing that was really telling was everywhere I had urine and manure, I actually had yield, nowhere else. So what was the problem? I had a nutrient deficiency. I had poor establishment. So here I'm going to talk to you a little about, this is some technical details on no-till. You need a good drill. Don't buy the cheapest thing that you can find unless it's actually in good shape and you can use it. Think about having more than one box and try and be able to put fertilizer in furrow. You want to be able to put the fertilizer in furrow. You really do. And if you can get a disc drill, that's where you want to start, because the disc is going to cut through things. Now, did I have problems with hairpinning and stuff? Absolutely, I did. But I'm going to go through how I started. I'm 2 years in, so I'll share. I'm going to share the good, bad, and the ugly, and you've just seen the ugly. So then you're going to see the bad. This is the soil microbiometer, because I always want to talk to you about how to test, right? Need to talk about testing. Soil microbiometer is a great test. It's going to give you some idea of what is your level of microbial activity. You can do it on the back of a pickup truck. You can do it on the picnic table. It's a great little test. This is my grazing manager, Aaron Sawyers. He's testing it out. We're testing out the rangeland, just trying to see where we are, trying to understand at the beginning. We did infiltration tests. We did all of that. I was lucky if I could put a 1/4 inch of rain in the soil in my crop ground. And that was only in certain spots, probably where there were gophers. I like measuring sometimes I'll measure respiration as well with Solvita. I always measure it in the crop. I don't take soil out, because what they do when they do the basal test for Solvita is they dry the soil out, they grind it up, and then they re-wet it. Okay, bacteria grow in 24 hours, so what do you get a measure of? The bacteria that can grow in 24 hours after it's been dried and milled. So that's an issue. So I like to do it in the field, and it's really easy. You get the jars, you get the tabs, you write the time on the top, you put the lid on top of it and you write the time, and then you can come back at any time and you can calculate your rate of CO2. And so the first thing you do is you find the spot you want to measure, and you always want it next to a plant, always, because you want the effect of the rhizosphere, right? So you screw in the jar a little bit just to disturb the soil, because you know that when you disturb the soil, you're going to get a puff of CO2. And you don't want to have that right away. So what you do is you let that go, open up the jar again, put your tab in, and then screw it down again, and then try and make a good seal. And then come back whenever you're ready or whenever you've seen a color change, and then measure it. When you have a disc drill and you go into too wet, oh, look what happens. Sidewall compaction. So now I don't have horizontal compaction, I have vertical compaction. So what do? Well, first off is, if I'm going to have to fix something, and I might have to fix it with some more tillage, I'm going to fix it. So that's where I get into cover crops. I get into alfalfa with deep roots. Maybe I've got sunflower or safflower or something with a big root system that's going to solve my problem, because I don't want to do the tillage again. So yeah, I'm starting from a cover crop. So that's my cover crop. Looking pretty sad because it didn't get much moisture, because that's what it went into. And that drill wasn't, I have a new drill now. Not a new one, but I have a different drill, because that one wasn't adequate for what I needed. I needed to get into stuff. I needed to have more hydraulic pressure. I needed to be able to cut through. I need a better coulter on the front to move things. I need a better press wheel to close things up, because closing the furrow is just as important as opening, by the way. You need to close it, because I mean, in the dry conditions, maybe not as bad, but it's different, because in the dry conditions, if I don't get it closed, then it cracks and it opens up, and the seed just like, oh, where is it down there in that canyon? And in the wet conditions, it's a slug superhighway. And I've lost there too. So you want to get that furrow closed. Obviously I want to put some, and if I'm really struggling with organic matter, because I'm lucky if I find 0.5% organic matter right now, and I say find because in places I do find 0.5%, and if I take the average of the field, it's just slightly less than 0.5%. So I'm actually putting in compost pellets with my seed, because I want that sponge in and around the seed. So I actually want the seed to have the moisture when I get it and hold on to it. And there are some nutrients there, but I have good cation exchange capacity with that. So I'm going to have the nutrients from the fertilizer that's gone with it, because that's in with the pellet. My seed's above, pellet, and the fertilizer's there. And they're all mixed together and they're going in. So what happens when you do this, and this is a different experiment, this is how I started doing that, you see this. So now all of a sudden I've recovered my eroded knolls. And because what is soil erosion? I mean, it's lack of organic matter. So if I'm going to reclaim subsoil, I need more organic matter. Sure, I could grow it, but I might want to go a little faster, because I'm really impatient. I'm going to grow a little faster, so I'm going to use manure, I'm going to use something, but I'm going to get in and furrow, because if I just put it on top, it could still blow away. So I still want to try and get it in the ground a little bit, and I like to do it in furrow. And then you got to have a little help from your friends. This is my little black beauty, and she was the first calf of my herd. So that's why she's my black beauty. I've chosen these cattle, this particular cattle, because I can look them in the eye. So they're not very big. They're nice. They've got big capacity, so nice big round bellies. And you can see broad muzzles. And they're adapted to drought. They're also being selected to not carry a whole lot of flies. And no, they're not purebreds. But that's the whole point. Hybrid vigor, drought. So that's the other thing, is I need dry land cows because I'm in dry land, right? So this is the other part of my plan, is to graze what I showed you before, to start grazing this using my cows. Well, I couldn't afford enough cows, so I had to rent cows from somebody too. So I need some of the ground for that, but not my cover crop ground. Because we're actually doing high-density stock grazing, so we're putting in the electric fences and we're moving them and trying to build the soils as well. So now I'm 2 years in. The first year, the cover crop was an incredible success. It was mind-blowing. The next year, it was an incredible disaster, equally as mind-blowing. Just didn't get enough water. Looked like we had established things really well coming into the fall, and then it just in the spring, even with the moisture, it just I was like, well, what has really happened? That was when I was like, okay, new drill, different drill. I didn't get seed to soil contact. I put a lot of seed in the ground, and I don't see the establishment. And then some of it germinated way later. Like some of it germinated like 3 months later. And that is seed to soil contact. That's, you know, not getting the depth right and things like that. Because it's really hard to get the depth right when you've got all that sod in there, right? Because your drill is trying to adjust to the ground. And so you need that dynamic hydraulic pressure, because otherwise you're going way too deep when it's soft, and you're going too light when it's hard. And you're like, okay, this is an issue. I need something that goes through this a whole lot better. So now I get to the 6 to 10 year mark. So what is my expectation? Well, I have cattle and I have the opportunity to put in forage cover crops. That means that I can rev the system a little faster. If I were just cropping, it would be very hard to build organic matter. I know that, and I'll let you know as I go forward, you'll be able to follow this. I expect that at the end of 5 years, I will be up at least at 1%, if not over 1% organic matter. And that is my goal, and I think I will achieve my goal. So anybody says you can't gain 1% organic matter in 5 years, I'm going to defy them. I've defied them before. I'm going to do it again on my own. So we'll see. And you know, maybe I'm going to eat my words. It's possible. And I'm prepared. You know, I have lots of recipes for crow. I can do it. But once I get past 5 years, this is what it should look like. I should actually see it. I'm not going to see a bunch of grass on the ground. I'm going to actually see real organic matter, real crop residue. I'm going to see that. I'm going to start to inhibit weeds. And now I really am going to need a good disc drill, because I'm going to have to go through that. But I'm also, you know, look at that. Now I'm holding a bit of moisture, right? Now I'm taking some stuff in. Now I haven't got erosion because I've got cover on the ground. I've armored up a little bit. And now I've even got better. I've got better cation exchange capacity. And more importantly, I am accumulating phosphorus. And most people don't realize, like, everybody thinks of phosphorus as an inorganic nutrient, but phosphorus is actually an organic nutrient too. And I can accumulate phosphorus. And I start accumulating phosphorus, I start accumulating nitrogen. I'm not disturbing the system. The system is starting to recycle. I can now not use as much fertilizer. Because before I had to increase my fertility. I proved that to myself, even with the cover crop. I didn't put any fertilizer with the cover crop. I made a mistake. This year, fertilizer with the cover crop too, because I didn't have the nutrition in my soil to even recycle anything. So for the first few years, I needed to use more in order to get to the point where I could use less. And then I can start to play with temperature, because now I can seed to temperature, and I can start playing, understanding that I can seed to temperature, because I don't want to put seeds in the ground when it's too cold and then have them wait for a week, 10 days, get some water on it, and then all die to disease because they can't grow fast enough. So it's better, and I understand you have a lot of acres to go over. You can't get over them fast enough sometimes, so sometimes you start a little early, but you want to hit your sweet spot where the majority of the acres you're going over them at an appropriate temperature for seed germination. And then you're going to be a little hotter on the other side, always, but we're not going to worry about that too much. I mean, you do what you got to do. More mulch on the surface of the soil is always going to stop me from water erosion and wind erosion. So I'm going to keep that armor on there. I know it's going to cool things down, but I'm okay with that because that means I'm going to hold more moisture. And when you haven't even got 0.5%, you need to hold every little drop that you can manage. And eventually it's going to improve the water infiltration because I'm going to hold more water in that mat, right? It's like a sponge now. And so now at least it's going to go down a little bit. But I still have a problem because I probably have either built up nitrogen or I have little pockets where I've accumulated a little bit. And so now I use my legumes and, oh, lo and behold, I got no nitrogen fixation because I got excess nitrogen in there. That's okay. You go for things that I've grown a lot of brassicas in my cover crop. I'm growing brassica forages in the fall because they're really good for cattle. They'll put on a lot of weight with them. I'm growing that because I want the decomposition to happen. I need my earthworms and stuff to start really working. And I'm going to just put up with a little bit of a problem for probably that 6th year because I've been using more fertilizer. I'm going to put up with having some issues with nitrogen fixation. It's always important as you make this transition, your family need to buy in, all of them. And because it's going to be hard and everybody needs the support as they go forward, even in the 6 to 10 years, because that's when the transition is a teeter-totter, because some years it's awesome, and in some years like, still you're asking, why did I ever do this? But then you get into that, 3 generations of no-till farmers and they're counting earthworms. And they know that they got 7 to 8 in a spadeful, and they know that they've got there and things are looking really good. And we know that we can do this with, if you look there, direct seed, look at the species diversity. Now I stop tilling, and I actually have more diversity of earthworms. I don't just have 3 from the plowing and the mulching. Now I have 5. I have 5 earthworms in there. And they're all earth workers. I'm starting to get really, can I go to a pasture? In Argentina, the system at first was, they'd have like 6, it was a 12-year rotation, and 6 of those years would be pasture. Think of what happened there. Their system was so successful, and they were so successful at no-till because they were always going from a pasture system. So a lot of them never really experienced the problems that we have. Yeah. They grazed it super hard in the fall, let the winter take it down a little bit again, grazed it super hard again, and then went straight in. And if you did that well, you didn't have to spray. Sometimes you had to spray. Occasionally you'd have to, throw some chemicals on there. But even sometimes you can just put a base oil on. And that'll stunt it enough that your corn crop will just canopy over and you'll be done. And the first year after a pasture, sometimes instead of using a planter on wider row spacing, you might use your drill with your corn and have it on tighter row spacing so that you cover the canopy. Yeah.
How far different would pasture situation be from an alfalfa situation?
Not that much different, except alfalfa and alfalfa has a big woody root. Okay, but that's the beauty of alfalfa, is that big woody root. But, you know, with the alfalfa, I would say that you're looking at the same thing. You're either you're gonna hay it hard, pick your timing, hay it hard. Of course, full flower and you hay it really hard, you can really knock it down a whole lot. And then if you can get in with something else after that, you will, and really canopy over. The key thing anytime you're out competing a perennial is you cannot you can't scrimp on seed. You have to oversow. And you have to have something that's aggressive and grows fast. Oats will grow really fast. Barley will grow really fast. Corn can grow fast. Milo will grow fast. But you need something that grows fast. And once again, it's like, okay, how much is not enough residue? In this case, everybody agreed this was not enough residue. And most people would cringe at that. But then we get into the next phase, 11 to 20 years, and things are really cooking now. And if you do things in the first 5 years, if you don't use enough fertilizer, you will have nitrogen immobilization. Because all of a sudden, all the biology in there is using up all the nitrogen, using up all the trace elements, and your crop is going to starve. So you need to add trace elements, you need to add more nitrogen, you need to be paying attention to that so that you take a crop. Because nobody wants to change a system, you're changing a system. So you want to take a crop, we need to take a crop. So make sure, so you plan, when you make the transition, plan to use more fertilizer. Plan for it. I am. Well, now that's interesting. I am a tissue tester. I like, because what is the best indicator of how much the plant's getting? The plant. So your plant is your best indicator. So I like to use plant tests. Now, a lot of people, there's a lot of talk about sap testing. Sap testing is really expensive. So how do they do sap testing? Anybody know how they do sap testing? No, actually, that's the point. Nobody does know how they do sap testing. Because they don't like to tell you. Some people actually suck everything out of the leaf. There's one guy in Oregon, that's what he does. He sucks out everything. He puts it in a high vacuum and then just sucks it out. And there are other people who freeze the tissues and then just spin out the liquid. But if you're testing the sap, should it be clear or cloudy? Probably clear, right? Because you're testing the sap. What's in that midrib of the leaf? What's not, you're not testing tissues like we are, you're supposed to be testing the sap. If you want to know more about how sugary the leaves are, anything like that, people use bricks. But if you actually want to link that back to chlorophyll, there are glucose testers for people with diabetes. And they have this little pin in there that you poke yourself with, but you can also poke the midrib of a plant. And it gives you, if you do this at about between 10 and noon, it gives you a drop of, you guessed it, sap. And you can put that in the meter and it will give you a reading on glucose. And then what is the first compound that's made from photosynthesis? Glucose. So you can actually make a calculation and get back to the rate of photosynthesis. And all with a little glucose meter. So I use glucose meters like that. It's another, somebody told me that I'm kind of the MacGyver of maybe that comes back again to that Scottish heritage where I'm just so cheap. I don't know. Actually, I would say, I was telling somebody, actually, I think it's sort of my background as an engineer. I look at things a bit differently because of that background, I think. But now my soils are biologically active. My nutrient cycle is being mediated through biology. I can actually start cutting back. Now I can get more for less. Yes. Well, I've done more to less in 5 years. Like I'm doing right now at the Ballot Ranch. I start at year 0. I'm using fertilizer, despite how expensive it is right now. So I'm like, okay, we are going to intercrop because fertilizer is really expensive and we need nitrogen, so we are going to intercrop a little bit this year because I need to use plants now to feed my nitrogen. So I'm going to treat it more as an organic experiment, and off we go. If I can get my roots in, I can get the cover crops growing, I can get the livestock integrated, I can do it in 3 to 5 years. Okay, that's the if. If I can't, it's going to probably take me 6 to 7 to really get a system where it's biologically functioning. And it's serving its own purpose, and it's got enough services that I'm getting a lot out of it, and I'm not putting a lot in. And of course, the weather has to cooperate, which we all know it doesn't. So, you know, I'd like to say 5 years. You know, that I think that for me is mostly conservative. But if things really went wrong, it could take me 6 or 7. I know that. So now when I get to this point, the only thing, you know, this is where you really are seeing you can have everything growing all the time. You never have to take a break. You might be able to double crop. You may be able to relay crop. You'll be able to do things that you didn't think you could do because your soil is going to be capable of doing it. You're going to have the water retention. So now you don't have to worry about water as much because you're holding water. Not only are you capturing water, but you're holding it. So now, and you've got cation exchange capacity, so you're really working. You've got the mycorrhiza network on your side. They're feeding each other. Now, I've developed that beforehand, but now it's fully in place. Now it's like you've developed your entire infrastructure, and now all you're really doing is tweaking. You're just making little changes to suit yourself. Maybe you're adding another crop. Maybe you've decided you're going to try a new crop. Or, you know, you can add this other crop into your rotation, things like that. Now, you know, and you're feeling like, okay, I'm not as financially stressed. I'm not as stressed about my crop. I'm going to take a crop every year. I know this is going to happen. And the mycorrhizae are helping you with that. Lots of mulch can be a challenge. But for who? Not necessarily for the plant, but it might be for you. And part of that is the paradigm. What do most farmers like to see? Black soil. Weed-free, plant-free soil between the rows. And I would say dirt between the rows. They want to see that. You need to stop wanting that. That's not an easy thing. It's pretty. Try chocolate. You know, but try to just like overcome that. It's not going to be easy. It's sort of like one of my friends who his brother owned a dairy, and he was growing all the feed for the dairy, and he was up by Logan actually, and he was growing all the feed for the dairy, and he was always fertilizing the grass, and I'm like, why are you fertilizing grass? It's grass, man. And he goes, because I always do it. And one day we were teasing, and his son came back and I said, so how's it going? He goes, oh, I pulled out the IV, and I am really struggling with nitrogen addiction right now. And he would call me every now and again. He goes, I want to fertilize, Jill. I so want to get out there and fertilize. And I'm like, no, John, don't do it. And so we called it Nitrogen Anonymous. And he would call me up and he'd go, is this Nitrogen Anonymous? And I said, yes, it is. How can I help you? I want to fertilize. I so want to fertilize. I'm like, no, stop. No, do you really need to? Do a tissue test. See if you really need it. So then he started tissue testing, and he's like, you know what? I was like obsessive compulsive about tissue testing because I knew it needed nitrogen. And it was come back and it didn't need it. And I didn't understand. But then there's this other case where as you go farther into this, things actually really change for you. And the dynamics of the crop change. So with one of my seed potato growers in Montana, Jason Kim, as he started getting into the system and started growing things with covers, I think it was the second year, he was sending in petioles, because that's what you do with potatoes. He was sending in the petioles all the time. And they would always come back, you need more fertilizer. Well, you're looking at it, it's like, no, really don't. The next week they go in, now it's dire. Third week they go in, your plants are dead. And it's like, well, clearly they are not. So finally, the state test lab, head of the state test lab comes out, because he has to see this for himself. And he didn't want us to take him around. He had to just give me a map. I'm going to go out and look at these fields myself. He said, I'll find the one. We're like, okay, see ya. Disinfected everything, and off he went. Comes back and he said, well, where are these plants? And we said, they're here. And we were waiting for him to come back, and he goes, they're right here. No, that's not them. It is them. Well, this can't be. Our tests don't lie. And so he took some more samples. You're not taking the samples right. He goes, you took the samples right. It still says that they don't have enough, but clearly they do. Organic nutrients. Plants take them up in a different form when all this changes. They adapt. And the whole system changes. And then we have very big differences. And it's really hard to comprehend sometimes, because it's like this thing where 1 and 1 don't equal 2, and 2 and 2 don't equal 4. They equal more. And you're trying to figure out why that happened and why this cascading effect happened. I'm not going to tell you I know why, because I don't. All I know is that I've seen this, and I've seen it happen over and over again. And probably we should start to study it, but we only have so much time and so many resources. So, corn emergence with the cover crop. Now, obviously we want a full service provider. So this is what happens when you have a full service provider. You've got carbon, nitrogen, phosphorus, sulfur mineralization. Sulfur being a really important one, because we want sulfur oxidizing bacteria to keep going. We need to probably add more carbon-based crops, because we're capable of growing a whole lot of broadleaves now. And we're probably not growing enough carbon to keep the system going. So now we're starting to see some bare ground again. So it's time to put more carbon back into the system. When you grow alfalfa, 18 years, continuous wheat, this picture is, you can still see where the alfalfa was. Alfalfa is nitrogen in the bank, nitrogen, organic matter in the bank. See where all those high spots are in there? Mustard. Breaking things down, nutrient cycling. PLFAs, cereal rye, broadcast nitrogen, cereal rye, in-furrow nitrogen, rape clover, cover crop, that's a cover crop for maize, corn mustard, corn on corn. Which one do you want? Not corn on corn. Bacterial to fungal ratio, and I was talking about this before. Bacteria to fungal ratio, somewhere around 8 to 10 is quite fine. If it gets down to 6 or 7, I like that a little bit better. And you do need help from your friends. You need to come out, you need to have a group of people around you to help you and support you as you go forward. There's no point doing it alone. And your predators, remember your predators are your friend. We were using, that was anhydrous with the cereal rye in furrow, and you can see that's not very nice for the protozoa. So we're building protozoa. You all saw this before. You can increase your crops. You can do it. And ultimately, it's going to do a whole lot better. This is what we go for. I do not spray insecticides. Because what aphid gets through that? in inverted soil in the Palouse, so much water runoff that the topsoil was buried under the mineral soil from the hill. So you can actually see it. There's a dark layer, he's pointing at it, and above it is the light soil, the mineral soil, because of the erosion that had come from the top of the hill and covered over the topsoil. You know, people pay to remineralize their soil. And just give me a second, McKinley. And then I talked about this. That brown line is the potassium wringing out the chloride and the sodium in this leaf that's being exposed to irrigation water that's pretty high in that. That's how you get potassium deficiency. So the rate at which your soil transitions to a full service provider is really up to you, and there is no right way. One size fits no one. And you have to integrate the culture, because every farm has its own culture. Every one of you have your own risk tolerance. And how much time it's going to take is completely up to you. But you know, just begin. Yes, Aussies have a term, have a go. You don't have to have a big go. You can just go on a small scale. So thank you, everyone. We're on time, and I know McKinley has a question. Mm-hmm. Yeah, it does. You can over-mulch a soil. So this is the same thing. You can over-mulch a soil that's completely dead. I mean, this is about a weaning process where you have to think about, how do I make this soil thrive? And a little bit of mulch, and this is not a bad thing. You might have to sort of fluff it in, like, you know, use a joker or something like that, or a rotary harrow, and actually rough up the surface and create a seed bed or some kind of an inoculant bed for it, and then go from there. Sometimes we have to do a little bit disturbance. Disturbance hypothesis is not a bad thing. In ecology, that's fire is a disturbance. Putting other plants in a pasture is a disturbance. Cattle on, you know, high density stock grazing is a disturbance. But a disturbance is just like a conflict. Sometimes it makes us stronger, and it helps us to move forward. Yes?
You talked earlier a little bit about inoculation. I think you're taking like you don't always inoculate. How do you determine when to and when not to?
Well, one of the things is, if I'm going to inoculate with mycorrhizal fungi, I'm actually going to do a little bit of an assay to see if I do have enough inoculant potential. If my inoculant potential is very low, then I might be going to inoculate, and I'm going to inoculate seed. And I'm not going to use the full rate. I'm probably going to use half the rate that they suggest. And I'm going to try and put it in. There are some ones that you can put in with legume inoculants. And once again, legume is a tripartite symbiosis with mycorrhiza as well as a nitrogen fixer bacteria. So if I can put that all into a granular, and some of the granular fertilizers will do that, there's some liquids that will too, then I can really make those legumes sort of build the inoculant density. And if I want to build the inoculant density, because I have to understand canola might take it down after a year, then, and if I want to build back my mycorrhizas, then I always need to have something that hosts them all the time. So that's where your companion crops can be really helpful, because you always have something growing in there, something that hosts them. That's why intercropping works too. Does that help? And then if you do inoculate, you know, we know, for example, with rhizobium, that with no-till, we can still find strains that are 20 years old in the field because they last. And the only reason you would re-inoculate with rhizobium is because it helps your other crops too. If you have leftover inoculum, use it on anything else. Rhizobia is a free-living bacteria. It's a plant growth promoting rhizobacteria, and it commits suicide when it forms a nodule. So it can use other things, but you know, and then just check. Dig up your plants. Do you really need to use an inoculant every year? If a new one comes out that's better, use it. It's cheap insurance. Anyone else? Yeah, you're in there.
I was just curious over the last 2 days, you talked a lot about plant interaction,
Mm-hmm.
like alfalfa and cornmeal.
Oh, they like each other.
They love each other. Where do you have a talk on that, or is that just on your website or poetry? Just talk about that plant interaction and benefits. What resources have you gained that knowledge?
From a woman named Christine Pilou. Yeah. Peilou. And another woman named Christy. And her surname is Christy. And I can't remember her first name right now. She's British. Both of these are fairly old. And Christine Pilou was modeled interactions between plants and plant communities. That's going to be a really heavy read. I know people who had her as a teacher at Dalhousie and at Harvard and thought that, and this one woman said to me, she said, I was so confused that I thought I was brilliant at it until I did the exam and failed and realized I knew nothing. But she modeled them. She was brilliant. Christine Pilou was brilliant. Christy, and I think it's Christy Newman. I'll find the paper. But they also talked about a grassland and all the interactions. Oh, and Steve Bardet, also from Britain, has talked about the plant interactions and how communities work together and how they support each other. There isn't a lot on it because it's a complicated topic, but you can see it works. Yeah, and then some of it's just trial and error. Like we know that chickpeas and flax like each other, lentils and flax like each other. They'll out yield. And there are some people that have been intercropping that have actually figured out what out yields. So you can always try that too. And just, you know, get in with people who are doing that and follow them and see what they are doing. See what they're learning. Like we put faba beans in with durum wheat. We liked it, but we got some greening because the faba beans liked it so much and the wheat liked it so much. They grew at equal height. So harvesting the wheat was kind of a bit tricky. Not to have faba beans, and it didn't work. We had faba beans. So, and yeah, of course we could separate them, but we still had greening on the wheat, so, which isn't a good thing. I have, and I am going to do that as we go forward in the net with the community. That's why I've done it. I mean, that's why Sarah talked me into doing this community thing, because it was like I can't be everywhere at once, and it was getting too crazy. So this is a way that people can come to me. So yeah, and you know, the next one is amino nitrogen, because that's what everybody in the network wanted. It's like, yeah, we want to know about amino nitrogen and how that works. And like, okay, that's going to be a 2-series talk. Okay, that's fine. We're on it. Yeah, but it's a community. It's not just, and do we, oh no, I don't know anything about that. We need to find somebody. Oh, so-and-so, they talk about it. Let's go get them. Yeah. Yeah, on my website, you'll see a link to the community, and then you follow the links. And if you have any problems, you can just email the chat, and Sarah will come on and talk you through it. And there was another question, yeah. It was a double disc, and it wasn't, no, and and I don't have any problem with Great Plains. I'm not going to tell you that. I have a white planter, and that's an old one, but you know what? It works really well, and those things are kind of bulletproof. So, and I have a John Deere disc drill, air seeder. I do. and I'm not giving it up. Yeah, you know, I mean, for a long time I had a 1580, and it was just fine. I mean, I put the grass seed box on it, and it was all good. I could do a lot of things with that. And that's the important thing. I also had a 750. I love that too. Grass seed box, but I just can't get the soil penetration without the hydraulic pressure. And that's, again, that seed to soil contact. And I don't know a lot of these other ones. I mean, there are a lot of other drills out there, and I've worked with some other ones, but it's also about what you can pull and how much horsepower you need. And, you know, I don't need a really honking big tractor. I mean, I like them, but I don't need one. And so I need to bear in mind what I can afford for horsepower and what I can pull and still get up the hills. And some of them, there's one drill that will go through anything, and the name of it just escapes me right now. It was designed in New Zealand. And then there's the Smart Seeder, too, out of Canada, which is really interesting as well. You know, 60-foot seeder, everything is on the box at the back. It's like a planter, and you can control everything from an iPad. It's a fancy thing, very expensive. I can't afford one of those either. And right now, with the ranch, we just have, I mean, I only have 800 acres of farm ground. The rest of it's all grazing, native grass, so, yeah. Okay, well, I think we probably out of time, but thank you everyone for taking the days. I really appreciate it.